Okay, this is a video about Jupyter notebooks. I'm really just kind of sharing my amazement with them rather than trying to educate on how to use them because I don't know enough about how to use them yet. But what are they? So a Jupyter notebook, if you're a data scientist or um, a computer scientist, or you're doing signal analysis or applied mathematics, or you're a student of any of those kinds of things, you probably know what Jupyter notebooks are and you've probably used them or something very similar. If you're a software developer or you're hardcore into the field, you're producing code commercially or professionally, you may not see the point of Jupyter notebooks, and I get that as well, and I'll come back to that issue. But let's look at one. So this is a static view of a Jupyter notebook, which is not ideal. But you can see it's got code in it. It looks like a word processor page. It's got an image, and it's got text that you can read, but it's also got code. Now, the thing about this code is when you're running a live notebook, and again, I'll get into the difference in a bit, you can run this code and see the output and edit the code. Not only that, but these notebooks, or the environment in which you use these notebooks, integrate very well, very easily with math libraries, graphical data representation libraries. So you can do charts with live code. So you can have sliders and buttons, and you can move the charts around on the page. You could change the code on the page. Right, so why is this so cool for me? Alright, well, let's go back to what I was doing. So I'm studying a thing that requires some coding, and I am, just to kind of clarify how this works. Okay, that doesn't, there we go. So I'm watching these lectures on cryptography and reading the book that goes with it. And I'm taking notes. So for example, I study the shift, Caesar and affine ciphers, or affine ciphers, take some notes, put some images in which are screenshots of the book, and then I write some code and I show the output. And you can click on this icon and you can get to the code. This is on my GitHub website, so you can you could download this if you want, and use it yourself in your own Python IDE, or you can just look at it here, and thus I can do the same thing. But it's quite clunky, especially if we look at, say, homework. So reference the book, question from the book, some code here, use that code to find this answer. Well, it would be kind of nice to have that code on this page, visible. You can run it, or I can run it, and get this output. If I don't do that, then I either have to put lots of notes, comments in the file to explain what things are, and I'm quite minimal here, so I might have some problems, if I come back to this in a year and try and work out, okay, well, how does this work? I mean, I try to write it clearly using, kind of English language, easy to understand variable names and stuff, but still, it would still be somewhat nice to have it on a page like this, where pretty much everything is on the one page, and I can play with it here. So the main reason for this blog is not for other people to see it, though I do like that, and it would be nice to have people look at it and give me feedback. It's so that I can kind of pull together all the work I've done and all the resources I've used and all the homework I've done in one place, so that I don't end up with just a load of files all over the place on my computer, and and find it very hard at some point in the future to go back and go, okay, I need to restudy or study again this kind of concept, and try and work out, well, how did I study it in the first place? Where are my files? What's going on here? Maybe I have to reinstall Python and Python IDE, etc. So vaguely, that's what Jupyter notebooks are and why they're better for me. So let's actually, before I move on to the desktop app, let's also just think about how I've been doing the coding. So normally I would run PyCharm, which is my chosen IDE, but you could use whatever, and load the project, and then I can run the program here and see the output in my console here. And then I would save the copy of the file. In fact, in other words, kind of push to the repository with all those files in onto GitHub, and then link to these copies of the files back on my blog, which is okay. It works, and it's still useful, and I'll still do that in certain cases. Now, in order to code Python or learn Python or pretty much any language, because you don't have to install Python on your local machine and an IDE and do it this way, you could just get on with learning to code in an online IDE, like this one here, REPL, which works. Live coding and video. Let's see if we can do this. This works. There we go. So yeah, you don't have to install anything. You can just learn to code here. Fine. Next step, install your language of choice into your operating system and IDE and go deeper. Great. So you don't have to do this. But how do we do the Jupyter Notebook thing? Well, let's have a look. So now, let's get rid of these. So now I can run Jupyter, and it opens one of these things and does some super whizzy thing, and then boom, it opens my browser. Then, for example, I'll go to a notebook I've already created. Let's go to the one we've already seen. Here it is. Now, this is running locally on my machine. So now I can click on this cell and I can run it. And it works. It actually runs the code. Pretty amazing. More amazing, perhaps, are these kinds of things. So it's run this because I have to. And yeah, there we go, it's run. Okay, so imported some libraries, and then I've copied some thing about creating a data frame. And it creates this data frame, which obviously one could make use of with further code. I've also quickly played with some math notation. So that looks like this when written, and then when we run that cell we get this lovely math notation. Now this LaTeX math apparently isn't just math notation, but it is code. It will run the math, and in fact theoretically is Turing complete, which is amazing. Then there's I've found a little thing here about the kind of some of the commands that are specific to these notebooks rather than Python. So if we run this, we get a whole load of notes about those. And then here's an example of a kind of more useful application. So obviously it's got something to do with this sine graph here. So if we run this, not only do we get the graph, but it's interactive. How cool is that? So obviously for me, studying a course where I want to be able to write code, write notes, write math, show tables, show charts, graphs, outputs, this is amazing. What else? So that's the desktop app. GitHub. So GitHub. Most people who've done any development work or collaboration with code know what GitHub is. If you're just learning a programming language in isolation, or you're a hobbyist or whatever, you're just playing, you may not know or need to know about GitHub. But basically what it is a place where you can keep repositories. And repositories are, how best to explain this, a collection of files. So they're in a folder, and in fact quite often what I am doing is mirroring a folder. So let's have a look here. So this is this folder. These files are these files. Basically every time I update one of these files on my local computer, I can then run the GitHub app, and this will push changes. And there are some changes here. I changed something. What did I change? Don't know. So edit. I've changed these files. I'm now going to push them to GitHub. And that's it. They're now synchronized. So there's a synchronized copy of these files on my GitHub. Not only that, but all the changes are tracked. Now, can I remember how to show that? History. So this change, these were deleted, these were added, this was deleted, this was deleted, etc. So why is this useful? Well, when you're first writing code, you're probably going to be writing very simple programs, and then you think, oh, I'll make this a bit better, I'll add a way the user can input a number. Okay, now I'll check that it is a number and it's not some random text, or it's not two numbers, or it's not the wrong kind of number. And your code gets more and more complicated, and then it starts getting a bit buggy, and then you think you fixed the bugs, and then the bugs reappear, and then you've suddenly realized you've saved 52 versions of your file, and you're not sure whether it's version 37 or version 36, which wasn't buggy, and now you've got to go back to version 36 and then open version 52 and copy in the bits of new code until it breaks again, and then work out why it broke. Well, you could just go back through these changes and kind of reinstall or go back to a previous version without having to save the 52 versions of your file. You've basically just got the one version, the final version, and all the history of it saved and ready to be rewound to any of those points. Which is really, really useful once your programs start getting a bit more complicated, and especially useful if you're collaborating, because then you can see who did what change. Hopefully they've explained why, etc. So that's GitHub. You don't need to use it until you need to use it. So, okay. And so having said that, now obviously I'm using this as a place to save my Jupyter notebooks, and that's nice because I can open, or I can see, a static view of the notebooks directly on GitHub. So I can see this from anywhere. I can just log into my GitHub and see what is this notebook? Oh, it's this one. And I could download it and get on with whatever I want to get on with. Which brings us to another point. What if the person who's viewing your notebook or finds your notebook on GitHub, or what if you are not at your local machine and you want the live version? So here I can't run this on GitHub. I can't get the interactive slider, etc. Well, you can use a thing called my binder, and you can put the GitHub link in here and blah blah blah, launch your file. And I've actually done that already for this file and put a link in the file to that version. So let's click on that. Now it can be a bit slow. It's not like loading it in your Jupyter on your computer. We can see what it's doing here. It's doing loads of stuff. It's basically running a little server somewhere and loading up the Jupyter notebook. And here we are. Okay, so a bit slow to open, but it does open. Let's run this. There we go. Now we can run this, and there it is. So this is not running locally on my computer. This is pulling the file from GitHub to the my binder service, which then sends it to a server in the cloud somewhere with Jupyter notebook software installed, and runs it remotely. Now you could download this file, or I could download this file as a notebook and run it on my Jupyter locally, or I can edit it here. So I can change the code, run the code, and there it is. Incredibly powerful. So I can look at somebody else's notebook here without installing anything, using my binder, and I can play with it. I can play with the code, I can alter it, I can work out how it works. Like, I don't really understand all this code here. I mean, I know how to draw a sine curve if I work it out myself. But I can work out that, because we've imported NumPy, which is a math library, as NP, then we need to use NumPy to use scientific calculations. So in other words, pi won't run unless we call the pi function from NumPy. I can also make some guesses. Like, I can guess that this is where the dimensions, if you like, of this chart. So let's change that number. Run it. Oh, look, we got loads more sine waves. They're quite pretty, actually. I like that because it's nice patterns. Look at that. Cool. Anyway, so yeah, we can work out what this does by kind of playing around with it, which is really nice as well. And still have whatever notes somebody wrote here or explanations here, and seeing the output nice and easily without having to write, you know, a whole load of code to draw a box, to draw the line, to get the scale right. I mean, the whole world of learning there just to get a graphical output like this from a Python file. And I don't really want to learn that. I just want to get on with the math and see the output. So yeah, amazing stuff. Also worth having a look at some examples, which I did have. Yeah, here we go. So I pulled some examples off the internet of kind of good uses of this notebook software. So here's one that's about statistical data. So using scatter plots, histograms, KDE, cumulative probabilities, box plots, etc. Beautiful stuff, beautiful stuff. Here's one about Fourier transforms with audio, including spectrograms. Here's one about neural networks, so you can see it's nice for including diagrams with math notation, etc., etc. These are static, by the way, so these may well do things if I load them in a live version. And here's another one about plotting and so forth. So yeah, worth investigating. So what would I say about this? Well, I mean, recommendations. I don't really know enough about it to be very useful on this, but I could tell you what my kind of initial feelings are. Is for people like me who are doing a kind of somewhat academic investigation into something that involves code, this is brilliant. If you're not doing that, if you just want to learn some code, it's probably not where you want to go first, but you could, in the sense that there are some introductions to Python, for example, that are all in these notebook formats. So if you started using these notebooks and you didn't know any different, great. This is a fine way to learn to use Python. I didn't do that, and I would probably, my general advice would be, don't jump into notebooks if you're just learning coding. Just use online tutorials which will have IDEs built in, or use something like REPL, which I was just demonstrating. This thing where you can just get on and just write code here and see the output here, and then take the step up to installing the language locally, natively on your machine, and getting an IDE, and then see where you want to go. You may want to go towards notebooks or use notebooks as well if you're kind of studying academically, or you may not. And I would advise using Jupyter locally if you do first, before you get into using my binder to share publicly, because this adds another layer of complexity. And one of the things you're going to find with notebooks is you might be a bit overwhelmed if you're a bit noob to coding, because just understanding Python is going to be or whatever you're learning is going to be enough of a challenge. Having to then start thinking about markup languages. So how do you make this link to this, so it displays this text, and but it actually goes to this link like this? Or how do you get a data frame like this, writing this code? Or how do you write this code to show math? You're basically learning several different languages. So that might just be a bit overwhelming if your primary aim is to just learn Python, say. But at some point, you're going to find it useful, probably. So basically, I'm saying if you're a noob to coding, the route you want to go is probably something like REPL, or an online course which has programming, live programming built in. Then go to native installation of the language plus an IDE. Then go to Jupyter Notebooks if you want, or you may not want Jupyter Notebooks. You may want to start developing actual programs that you can distribute, or developing with other people, probably professionally, in which case Jupyter's not going to be what you want for that, because you're going to need a development environment. You're going to need to be able to produce standalone apps that integrate with multiple different operating systems, or you're going to need to push code to a web server. These are not going to be most easily achieved in Jupyter Notebooks, and indeed you're going to introduce a whole load of problems you don't need, especially things like if you download this Jupyter Notebook and you run it on a version of Jupyter that does not have matplotlib, this library, installed in its environment, this is not going to run, and you're going to have to find how to install matplotlib, and then you can run this file. Or it's not going to run properly. You can get around a lot of that by installing Jupyter, by installing Anaconda, which is like a kind of whole Python programming self-contained environment, and you get Jupyter with it. So a lot of these libraries will just be there anyway, which I would advise. It's the simpler way to get this. And actually, what do I want? I want this. I want this. Show you what I'm talking about. Yeah. So this. To install the Jupyter Notebook, the easiest way is install this, Anaconda, which basically installs this entire package, comes with its own Python. If you're careful about how you install it, it doesn't even conflict with any Python you've got previously involved. Basically, you've got to make sure you don't put Anaconda on your path. Yeah, and you're basically good to go. So that's pretty much it. I just wanted to kind of share my joy at discovering this thing. I'm gonna stop using the blog. So as it says, my last entry here is I'm moving to Jupyter. Brief explanation of why here, and I'm going to try carrying on with my studies primarily on Jupyter Notebooks. So yeah, amazing things. Very useful if you're a student of pretty much anything where you're likely to be using code as part of your study or explorations. That's it.